Good evening, everyone. I hope you've all had a nice little dinner and can really jump in and enjoy this part of the conference where we're going to be talking about some of the industry issues as it relates towards regulation and nanotechnology. Now, we've obviously got a panel here, so it's going to be a lively Q&A session, but I've asked each of the panelists if they would just take a few minutes to introduce themselves and really to outline what their particular interest is as it relates to the industry's view of regulation and nanotechnology. So I'll start at the far end with Mark, and if you'd introduce yourself.
Yes, I'm Mark Banish. I'm the VP for Quality and Regulatory Affairs at Nanocomp Technologies in Concord, New Hampshire. Nanocomp is a manufacturer of carbon nanotube-based sheets and yarns. We don't make the loose powders. We make these come out of our reactor fully formed as 4x8 sheets or yarns, kilometers of yarn, things like that. We are a company determined to do this right, and we are a small company, and the fact that they sent a member of senior management here, let alone invested me with the title that contains the term regulatory affairs, I think shows how seriously we do take this. I've been going out now for the past couple of months. We work already with NIOSH and with EPA and a bunch of other people. But what I'm looking for is I'm trying to determine internally what our EHS strategy and master plan should be. So I'm going out right now. I have worked, like I said, with NIOSH and EPA and some other local folks in New England. But I've been going out to these meetings. Last meeting I was at was on, good grief, Friday. And that was at Northeastern, and that was a bunch of lawyers. Before that, it was a meeting with a bunch of project managers for the defense industry, and before that, it was with a bunch of toxicologists. And it's like the old story about the blind man and the elephant. So everyone's going around feeling a different point, of the animal and trying to determine what it is. One of the reasons why I'm interested in coming here is because this is a more eclectic, perhaps disparate group of people. And I'm hoping to see some fresh viewpoints and different perspectives that will enable me to go back and work on our strategy.
My name is Jim Larkin, and I'm the CEO of a company called Scientific Methods. And I think I'm here because I may be able to represent the historian. I, in my prior company, worked for environmental health laboratories, and we lived through for 20 or so years a whole series of new implementations for monitoring by the EPA for volatile organic chemicals, and then pesticides, and then lead and copper rule, and then the unregulated contaminant monitoring rule. And so I think I can give a little bit of perspective as to how the EPA has worked in the past, and we can see whether or not that matches up with how they're likely to work with the nanomaterials.
My name is Bill Myers, and I'm here because I failed to answer Dr. Lieberman's email to turn her down, I think, and she had to find some place to put me. But I'm a founder and work for a small company in Angola, just 50 miles east of here, that has been trying to find companies to work with to add antimicrobial compounds to their line of products. And most of the technology and so forth, I think that you people have talked about here, I think is wonderful, and most of it's way over my head because basically I'm an engineer and don't understand a lot of the physics and chemistry and so forth that go with all this. But and we really worked with, what struck me is some of the stuff we work with is so mundane compared to a lot of the issues that you have covered, like for instance vinyl siding and waxes and paints, topical coatings for maybe FEMA-treated homes and so forth that we have worked on. But I think there's an awful lot of technology that really needs to be done. And when I listened to some of the presentations on how silver works and so forth, we heard all this. I haven't seen any papers that prove all that. But anyway, there's an awful lot of technology I think that needs to be developed, and it isn't all related to medical devices. I mean, there's a lot of mundane kinds of things that are important. Mold, treating fungus, making houses so they're maybe mold-free and things like that. So that's my interest in the conference in general.
My name is George Engle. I'm originally from Switzerland. I'm professor of international business ethics here in the Mendoza College of Business at Notre Dame. And my area is corporate ethics, corporate responsibility, and business ethics in international relations. Particularly, I've been teaching and doing research in China for 14 years. I regularly go back, and so I'm interested in more broader terms. What are ethical implications in the development of nanotechnology? I must confess that my knowledge is very, very limited, and I can learn a lot here, but I think the ethical dimension of what we discuss here is an important part of the problem, and so I look forward to our discussion.
Thank you, gentlemen. I think, Bill, you've touched on it very well for this panel, which is a lot of what I heard today was, in fact, over my head. I'm not a technologist, but we're all involved in the corporate side of dealing with the regulation that's going to come about as it relates to nanotechnology issues. And so what I'd like to get the Q&A started as you start to think about it, and I came up with a lot of questions that, my background was all corporate, Procter & Gamble, J&J, and Kellogg's. And we were constantly concerned about where regulations were coming in, the speed, the importance, et cetera. But I guess one of the first questions I think to sort of kick it off is, as you heard today, the complexity of the issues, what is the probably the most looming concern you would have as someone on the commercial side to deal with this evolving state? So if you would, try to give your thoughts on, or all of you, if you could, yeah.
Well, I'll speak for C&T makers. The one thing that I found most useful and emerging from this conversation was the whole concept of a taxonomy or classification scheme. I work with the ISO Technical Advisory Group for the TC229, and I have to tell you that paint drying takes on a festive air compared to our detailed discussions about nanotechnology and its taxonomy and its terms and everything else. I think that the presentations I saw today, specifically in the latter part of the afternoon, discussing these principles by which these things can be classified, they're going a long way toward helping us frame the problem a bit better. It's one thing to debate over what makes up a nanotube. It's another thing to talk about mode of action and things like that.
Well, we deal with an EPA-registered product, the patents of which are owned by a company in Pittsburgh. And I don't know, some of you may not follow this, but the EPA is, of course, very specific about what you can't say and what you can say. And for instance, we cannot make health claims. If I were to release something here about a health claim to the product, I'd get a phone call from Pittsburgh in the morning, probably saying that, you can't say that. And they're very specific. That we can talk about protecting a product against bacteria and mold and fungus and mildew and so forth. And of course, being registered with the FDA is a whole other can of worms, really, and very expensive to try to get people to adopt the product when you can't say certain kinds of things. For instance, almost everyone that buys or wants to use an use an antimicrobial compound want to be able to say that this will make you healthier. We can say that the table here, for instance, is protected against certain kinds of bacteria and mold and mildew, but you cannot imply that that's going to make you any healthier. Now, a logical person might jump to that conclusion, but you can't say it anyway. So registration and cost of registration and so forth has really been a big problem for us.
Jim?
I'm going to take the slightly contrarian view. Actually, Dave, I'm not that concerned. And if you look at it from the long view, and if I could just back up for a second, we've already agreed that the general population might not be that interested in the subjects of the functionality of different materials and whether they're in the nanoscale or not. They have designated a group of people. We're a representative democracy, and so the legislature communicates a certain vision of what they think is important. They pass it on to a group of scientists, and I think if we are willing to accept that these regulators are also scientists. They're government scientists. So we have academic scientists who discover things, and industrial scientists who apply things, and government scientists who govern, both in the sense of governance, but also in the sense of a governor on an engine. I think it's a pretty good triangle that we have going. And you know, when you look back on the last, well, say since 1975, 76, when the EPA got started, a lot of good progress has taken place, and I would like to get into how they might do that and how I suspect they will do that, but I don't think I'm quite as concerned as many of the people in the room. I think there is a process in place. It's messy. It's a little bit like watching sausage getting made, but you know, in the end, it'll be all right.
Well, I'm also not so pessimistic about this process, but I think there is also an aspect which I used to deal a lot in my field, and that is corporate responsibility. Even if regulations are in place or are being developed and set up, it is still a question what responsibility do individual companies have. And we know that BP now, with the oil spill in the Gulf of Mexico, or for instance Goldman Sachs, in the last few weeks we looked more closely at that behavior. So I think that is a challenge for each company engaging in nanotechnology development, and so how to understand the risks and the benefits, and what are the driving forces. And my point here is that if it's just to make money or to maximize profits, probably that's not such a strong motivation. I think more attractive would be, well, a kind of entrepreneurial spirit, or to create genuine wealth, to improve products and services, and for that we need a lot of ingenuity and guidance also, and that's a challenge for companies which is quite enormous in my view.
Let me just ask, because I think you've opened up some very interesting areas that I think the audience might want to follow on. But Jim, picking up on your point about being a little contrarian and not pessimistic, you mentioned about government scientists. I think I'd be remiss not to ask whether or not politics for any administration might play a role in the regulation of nanotechnology. Do you have any sense of that?
I can't speak specifically for nanotechnology, but I have been involved in expert panels that looked, for example, at what unregulated contaminants ought to be looked at next. And at that level, I didn't find there to be partisan politics. There certainly are a lot of strong egos. There's certainly people with very specific points of view, and they would argue them, and then, you know, the consensus of the group would be incorporated into the next round, the information collection rule, or, you know, the next notification by the agency. So in a sense, it's a little bit like, if any of you have ever been on a jury, it's a little bit like being on a jury. You know, everybody gets their say. There's 12 people. I've been on a jury, and I was amazed at how much information and new insights each person of the 12 was so much smarter than I, you know, was as I thought about the case that I was on. And I think the same happens a lot of times in these review meetings, where a lot of good thought goes into it. And so I'm not, you know, there certainly was an issue as to whether or not, how to say this politically correctly, the last administration allowed government employees to modify the statements made by scientific panels. I don't, you know, and I think that was a little bit of an aberration. I haven't seen it in the past, and I don't necessarily see it now. So while your point is a good one, Dave, I don't think in the trenches people are willing to sell their soul. They're there to say what they think is true, and they're also willing to let the group decide. And again, that makes, maybe I'm just a little bit of an optimist. That makes me optimistic. So,
Yeah, question?
I like mundane aspects. Can you give us a little bit of background on how much it costs to register something with the EPA, or how much it costs to bring a product in these different states through the steps, or just to give us a little bit of the overview of these procedures, because I'm very foggy in that area.
Is that left to me?
It could be anyone, but
Normally,
exciting would be a wonderful thing.
normally what we would do, I'm not sure I know how much it really costs to get the EPA registration label, but I think it costs quite a bit. What we normally do is search out a company that we really don't have a product, but we think is some intellectual property. We go to a company that might make a product for a hospital, for instance, and say, you know, this might be a good idea if the wheels on your cart were antimicrobial, because maybe you're rolling around a staff product, you know, on the floor. And what we would do is ask them to send us some of their polymer or whatever it happens to be, and we can add various levels, various loadings. I'm not really sure these would fall into nanotechnology because they're pretty big, relatively speaking. I mean, like 0.1% or something. And we would run a series, some people call it the ladder of loadings, and then we would then send them out for efficacy tests to a certified antimicrobial test laboratory to see how they would perform against a specific MRSA or VRE or maybe as mold or whatever it happens to be. And basically then all we do is present that to the company and say, you know, depending on volume, here's what it would cost you, and here's the results you have, and here's what we could do for you.
What time course are we talking for all this? 2 years, 6 months?
No, it really doesn't take us that long. We have injection molding machines that will make a standard test placard, so we can, you know, it's a molten product. We add our product to it. Sometimes we could send, there are what's called compounders, which are people who put a lot of additives. Most people don't know this, but in an injection molded part, for instance, they have blooming agents and slip agents and ultraviolet inhibitors and things like that. So they actually make up a concentrated pellet. A lot of companies just buy the concentrate already and put it in. We could do this in a couple months, really.
To follow up on that, I can speak from my recent experience with getting and working on something called a pre-manufacturing notice, and I assume a few people have heard of that. Have people heard of pre-manufacturing notices? Okay, what you have to do before you manufacture something which could technically be considered a chemical is that you have to file with the EPA paperwork, which basically talks about your process, what it makes, its byproducts, how you make it, everything about your way that your business or your process actually works, including byproducts, which is something in nanotechnology kind of gets slipped aside, that you forget that at its heart it really is chemistry, and there are byproducts like carbon monoxide or hydrogen sulfide or toxic carcinogenic metals. But away from the good stuff for a second and back to the process, before you do that, of course, that requires you, depending on how you're going to proceed with the EPA and what you're going to classify your business as, for example, you have to do a lot of internal monitoring. And so I go around with my little sniffer and do that and do tests and send those off at $75 a sample. And then I have to bring someone in who watches over me and verifies that. And then I have to bring someone in who watches that person. Yes, and so we have to be as clean as a houndstooth. I mean, this has to be absolutely above reproach. And I'm thankful that I've had partners like Chuck who've been around and made themselves available and have made their equipment available. Because the other thing here is that there's not really a lot of there really isn't a lot of technology out there to sniff out nanoparticles in the workspace, which is something we're working on remedying, but determining whether they're getting out is another problem. So you have a lot of upfront costs, and then going forward, depending on how the EPA looks at you, you can be looking at tox tests, and those can run, you know, $500,000, $1 million, and take a year or 2 years, which is a lot of money for a company. So you're looking at probably, I'd say, several $100,000 up front prior to filing the PMN. And then once the PMN is decided upon and you get your consent order back from the EPA, you may be looking at another $500,000 to $2 million in additional money.
Well, that was my
That's where I defer to Chuck. I mean, I'm not. I mean, I know he can fill this in, but basically, the nanotechnology, the nanomaterials group at NIOSH has been. Yeah. But OSHA, I have to say, within the state right now, I can't speak for OSHA, but this has not really come up, and we've had OSHA on site and all the rest of it. It really hasn't emerged as an issue with them. Mm-hmm. Yes, that's what we do. We work with the University of Massachusetts at Lowell, the Toxic Use Reductions Institute. We work with some of the professors there, and I'm very happy to say that, as you'll see tomorrow, we have a lot of containment systems around our reactors, and nothing gets out. Occasional little bit of soot gets out, but we are very sure that we're not leaking any nanomaterials. And the reason we know that isn't because I'm the world's best TEM expert. It's because I know people who are, and I'm only too willing to pay them a few $100s an hour to sit in front of the screen and tell me what I have. But yes, we do work with academics, and I really rely on them for a lot of the quality information.
Yeah, and thanks, Mark. And I'm the guy from NIOSH, not OSHA. On the regulatory side of the workplace, the Occupational Safety and Health Administration side, they are evaluating their current regulatory framework. At this point in time, they feel their regulatory framework is sufficient. However, they are looking at partnering with NIOSH to develop some more progressive materials through their consultation program to get good information out. We NIOSH, are very thankful for good partners like Nanocomp and Mark to have the opportunity to go into their facilities, to evaluate, to teach, to test, and to deploy any number of our technologies, from containment out to measurements and evaluations. And I think, to OSHA's credit, they want to partner with us as a sister government agency to develop guidance materials for other companies and deploy those through their consultation program. So that's probably the most activity that we've seen out of OSHA from the very beginning of the whole nanotechnology activity.
Yes, this information is extremely important for toxicologists also. So can you get information from you about exposure?
Oh, sure, certainly. We now have, it's been a very rapidly evolving process over the last 3 years. Over the last 3 years, we started with some very basic rudimentary visits and evaluations and studies. We progressed quite a bit. We now have a framework underway to develop a true industry-wide thorough evaluation of a number of volunteer sites and facilities. We continue to do initial visits at facilities. We're also now conducting engineering control evaluation studies. We want to package all of that and put it out as guidance, as publications. We've just issued a publication on our first 12 site visits, though we've done 26 of them by now. So there's a lot. I'm previewing a lot of what I'm going to talk about tomorrow, but there is a very good, healthy stream of activity going on from what I would call the NIOSH end of the non-regulatory but government agency work being done in the workplace. But it's feeding into the good framework for good policymaking by the regulatory agencies.
Question, do you see, I'm not trying to give you to preview too much of what you're going to cover tomorrow, but I think the
Changing my slides tonight.
I think the question about the different regulatory agencies, do you see any looming cloud in terms of, as more information comes forward about the different nanomaterials and how they relate and some of the unexpected properties, that there's going to be a conflicting views that are going to create industry problems?
I don't think there will be so much conflicting views as it will be you need to focus on the intended use of your material. If you intend for your material to be a medical device or drug, you know you're going to have to deal with FDA, and so it's incumbent upon you to understand what their concerns and what their definitions and what their research program looks like. If you're going to make your material because you think it's a really great additive to a polymer for this really growing industry called the nanocomposites industry, then you're going to have to deal with EPA, and without, you will have to make sure that you are still following whatever OSHA has to say about the workplace. If you're smart, you'll invite NIOSH in to be a part of your study. And so I think a lot of it will be a matter of you understanding the intended use of your material, what your markets look like, what your costs, what your barriers, and what your market entry costs are going to be, and the regulatory framework that applies most to your product. Certainly EPA with any of these materials is going to be a pretty big regulatory player because they've taken the first several moves with their pre-manufacturing and significant new use rules. And that's probably been the greatest amount of activity, both at the federal and the state level, that I've seen. And I don't really see it being in conflict because, as Jim said, the government agencies have learned through nanomaterials that they've got to talk to each other. And I think that's probably the healthiest and most productive thing that's happened on the government agency level. And I say that freely because I work for a federal government agency, but I haven't always worked for the federal government. In fact, Procter & Gamble is in my working history at one point in time. So it's very healthy to see that there's some very deliberate, if not forced, collaboration going on between the government agencies so that we don't have these conflicts that become a technology killer.
If I could add, the one place that I do think we might have that conflict is in California. California's Prop 22 regulations, and I'm on the Water Reuse Association, and some of their effluent rules are so strict. I mean, NDMA can occur in less than 10 parts per billion, whereas in a good glass of Guinness you get about 200 or 300, nanograms of it. So California would be the one place, if I had to predict where that problem's going to come up, it'll be there.
I would like to say a few words about the interest of business in having good, reasonably designed regulations. I'm from Europe, so maybe I have a bias and I'm more inclined to accept regulations. But it struck me quite often here with my colleagues and also with business people, I could observe some reluctance or even that almost sometimes regulations are by definition bad. And that can happen, of course. But I think there are three reasons which are important to notice, to take into account when we talk about regulations. One is, good, well-designed regulations prevent businesses from taking high risks with barely foreseeable consequences. So it is a protection for business. Second, good regulations provide a level playing field. We are in a market economy, and so competition should work, but on a level playing field so that the good guys are not punished for their good behavior. And third, they can encourage and support genuine wealth creation in nanotechnology developments. And all three reasons seem to me quite important. I'm not saying that all the regulations are good, but I think one can make a strong business case for those well-designed regulations.
Right back there, Prashant.
I just want to ask a question. How do you address this one globally? In the Western world, we are very much concerned about all the regulations. The big companies have operations all over the world. You strangle it here in the regulations. They just take it to China, India, where there is absolutely no regulation, no Clean Water Act, no Clean Air Act. So they can operate and manufacture with minimum cost, but eventually all pay. So how do you address this question?
That's a question for me.
Because you said that
Yes, well,
industries are worried about the regulation.
yeah. Well, I'm a little bit familiar with the situation in China, and I think in China it's going to change. There are important changes underway. And I know also that foreign companies, chemical, pharmaceutical companies in China, are very careful about drug safety. So they want to make sure that those drug ingredients they buy from suppliers are really high quality. And if not, they produce those drug ingredients themselves. But that's a small part of the whole question. And I certainly believe that there are enormous challenges. But there are also a number of initiatives, like, I mean, in China you have the new labor contract law, for instance, which many people don't know here in the United States, but it's an important step forward. There are other industry-wide initiatives in the oil industry or with regard to fighting corruption. With regard to nanotechnology, I don't know. I think that's too early. But if it's possible that the US and also European countries can develop reasonable regulations, that will certainly be an important contribution to address the global issue.
Just to add to that, there's a couple of things. First of all, if something is made in China, chemical or a material, and the EPA is considering nanotubes, my bread and butter, chemicals, when you bring that stuff into the United States, you have to treat it just like it was an American chemical. It has to follow the same environmental laws. It has to follow the same, all the laws. And one of the biggest issues there, and having had about 20 years experience working in coatings, formulations, glass, and other things like that, one of the biggest problems we had is when this stuff came in, not only would we not want it for reasons of having to deal with the EPA and become the importer and not have the support from the company abroad, but we would also find quality issues and other process issues, business issues that were just not compatible with us. So in some of these high-tech applications, you're finding that what's being a big barrier here is the fact that the stuff simply, for all intents and purposes, isn't as good or is not a plug-in replacement. Second, the other thing is that, at least where I work with is considered vital defense materials. A lot of the things go into aircraft, spacecraft, and things which I'm not supposed to tell anyone else about. And these materials there are therefore considered, vital war materials or defense materials. I forget what it's called, but one euphemism aside, the point is that you're dealing with restrictions on their import and their export. I wish I could tell you how many times in a year I get suspicious emails which are not written in proper English, asking me if I want to, have someone as an agent in Hong Kong or something else. We never follow up on that. But and again, with respect to regulation, we talk about environmental regulation and things like that. I'm sure people in this room have heard of ITAR and similar regulations about exports and how tightly these things are controlled. So there's lots of other barriers besides the ethical ones, just the plain, this is not going to work, or I don't want to take on this regulatory burden, or I can't do it because this is going into the new XB-12-7 missile.
One thing about practicing medicine has taught me is that incentives or conflicts of interest really control a lot of things. Let's focus on incentives here, because it's like incentives for the patient or the work we do things. To the panel, where do you see either compensation law or regulations where the incentives are badly misaligned? Where do you see those where they're badly misaligned with what you think you're trying to do, and how would you suggest that they would be rectified?
I'll take a shot at it. In some cases, if a regulator comes down on you, it is essentially a terminal event for your company. So that sets up a scenario where an ethical manager, so I ran a drinking water laboratory, and one of my competitors, an ethical manager, had a part-time employee time travel. So he intentionally put the wrong analysis date and time down. They notified the regulating body. They came in with a SWAT team, basically not only put that lab out of business, all the people who worked there, but it was a chain of 4 labs. All 4 labs had to fold. So, I don't want to sound like I'm whining, but I do want to say that if you get too punitive, you could incentivize somebody to do the wrong thing because they understand that every person that works for them no longer has a job.
How many people are we talking about?
How many total employees are we talking out of work?
Well, each lab would typically, say, have 30 people in it, so 120 people.
That sounds like a misaligned incentive from my point of
Exactly.
view.
Yeah.
Are there any others? Pick OSHA or FIFRA or anything.
Really? We're trying to target EPA. I'm used to EPA. I'll give a side comment on that. When I was asked to specifically target the OSHA chromium rule, and EPA had issued its own chromium rule, and as if the agencies didn't even talk to each other, but yet they were targeting very similar things. And I just found that was very interesting, because essentially, if they had changed the rules just slightly, they could have essentially aligned, and I found that it was misaligned incentives. So.
I was hoping you guys could comment on maybe some of the stuff we talked about. I know you connected with some of the things we said. But one thing I hear a lot of from maybe academics in general is this kind of minimax fear, right? Like we're all worried about worst case scenario sort of things, like over-regulating and driving everybody to other countries and so on. But you all either work for companies that operate here and choose the place where you work intentionally, and maybe don't really care that much about certain kinds of regulation. Oh, I'm going to lose 1% if I keep my company here rather than move it to Minnesota or like something like this. So how reasonable is it for us to be sort of worried about these worst case scenarios all the time? I mean, one of you even mentioned we work with really mundane projects. We make siding or something like that. And here we are worried about regulating nanosilver or something that might create this sort of EPA-like disaster. Does that seem reasonable, or is this sort of generally not all that important? I mean, I'm just looking for your comments on that. I don't...
Are you asking, are these burdens so burdensome that we would pack up shop and leave, or they would affect business decisions?
Yeah, and do you face competitors who really make these decisions to move elsewhere to, get the extra $20 an hour or whatever
Well,
it is?
I can tell you one thing, and that is that our customers are demanding EHS and all this type of stuff. The reason why, and I'll tell you, just last week I had a conversation with my president, and he basically told me that he viewed EHS above R&D. He said R&D is great, it's got the company where it is, but where you have to use terms like indemnification and liability now, and those are not in R&D's lexicon. To this point that having this type of function within your company is just part of advanced technology, advanced development in an advanced economy. And so we're not going to move to some place just because it's going to give us an easier time of it. There's a larger ethical issue here as well. One thing which I'll mention tomorrow is, my grandfather died of black lung. He was a coal miner. That's the legacy I bring with me to EHS, to all my work in nanotech. I can't not have that as part of me. And a lot of scientists are like that. They have a memory or they have a vision, and that affects the way they think. And it does enter into our corporate decisions. And one of the reasons why we're interested in developing these ethics is because we believe that it makes not only better products, it makes us better people, and it makes everything better. So in that respect, there's lots of internal dialogue, a lot of internal thoughts and perspectives and philosophies that affect it.
A different kind of a question. The whole conference is about how to evaluate and get a handle on unknown risk, because in certain applications they're moving into technologies they just don't understand what the implications down the road might be from an unintended consequence. So does this present a barrier to the average American company today from a capitalization standpoint, particularly with respect to investors in putting together large capital projects that are dealing with a nano-based type of activity, not understanding where all of the liability may be down the road? Could you comment there?
That's a very good question. I'm working with Professor Jackie Isaacs at the Center for High-Rate Nanomanufacturing to develop decision-making tools that will enable us to do that, to figure out capital costs. If we're going to have a certain level of safety in the plant and we have this much uncertainty associated with the quality of information, how much money should I go back to my investors and request? And I remember cost of capitalization and 10% and all the rest of that. So one of the things I have to do that level of analysis. The investors are expecting it. And when I go back now and we have our corporate board meetings, that's one of the discussion points, is how much money should we be setting aside for that? So in terms of managing it at Nanocomp, it's just become part of our process. It's just built into it. We understand this is part of business in the 21st century, and we'll just develop good tools that allow us to estimate the costs and deal with it and go on. But investors are not balking at it because they don't see it as unnecessary. They see it as playing by the rules frees us from liability or limits our liability. It sets barriers, and they're very happy with that.
Last question. Aria?
What kind of information from the science world? What kind of information from the science world would be helpful to you as you struggle to fulfill or meet the requirements of these various regulations?
For me, one of the biggest issues here is measurement devices, development of new measurement devices, ways of isolating what exactly it is about these materials that gives rise to these properties. In my role as quality, what I'm supposed to do is I'm actually supposed to look down at the atomic molecular level of our material and develop tests that telegraph back up to why this rebar failed or why this thing doesn't have the proper electrical conductivity. So I have to live in this world of seeing the atoms and going all the way up to the composite. In there, I'm fairly comfortable and I feel I can do things. But right now, there's a lot of issues in terms of rapidity, in terms of reproducibility, selectivity, and ease of use and speed of information around analytical instruments that, for me, that's what the EPA wants. They want environmental records, they want monitoring records, and they're expecting me to constantly upgrade and improve them. Now, I'm smart, but I do sleep, and I need help.
Anything else from the rest of you that want to add to that?
I would say the sort of the missing piece that I don't hear talked about much when I talk to people who are at the micron scale or the nano scale is the concentration. It's getting the analyte in contact with the target. And so I see all these great little experiments performed in 50 microliters of solution. And I just hope that, I know it's boring and mundane, but the whole issue of concentration is in many ways central to whether or not this technology gets deployed.
Yeah, there's a number of issues. I'm sorry.
Let me give you an example. Viruses, for example, occur naturally in environmental waters. To sample for it, you typically need between 100 and 1,000 liters. So how does a nanomaterial, particularly a stationary nanomaterial, even enter into a useful discussion about sensors or probes? So I just wanted to put that on the table just so we remember that eventually this stuff goes into the real world, and I just hope we think about concentration a little bit.
Yeah, there's a number of things that, I don't know, the word leaching hasn't been mentioned here, but certain kinds of products leach out into the environment, and some I wouldn't want to bring up here, but you probably saw them on CNN the other night about antimicrobial compounds, but the actual mechanism, whether it leaches out, how we can get smaller loadings, and obviously I think that these compounds are only effective on the contact surface if you make a large part and have to put it throughout the part. So mechanisms attach that or tag that with some other agent or something, looming agent, to get it out to the surface. These are all kinds of things I think that we just kind of screw around with and speculate on, but don't really understand very well. They affect the cost. And, if we could get the amount of antimicrobial compound down so that we wouldn't have to put as much in it, it would be a lot more apt. You can't believe how, petty conscious these companies are. When you go to a vinyl siding guy and say, look, you got problems with the mold on the north side of your house, and he denies it. I mean, he's the only guy that doesn't believe it. If you have a meeting with the people at the hospital that they have staff problems, they say, we don't have a problem. Like, well, the nurses here don't come here maybe because you have problems. It's just really hard to get those people because of cost. So anything that would give us a better understanding of how to make these things effective, I think would be a really big help in our business.
I'm afraid we're going to have to cut it short here because of the reception that is following. which is sponsored by Baker and Daniels. But I'd like everyone to show your appreciation to our panelists, Mark, George, Jim, and Bill. Thanks a lot. I'm sure they'll be out here to answer your questions.